Question 7a. So 7a says electricity can be generated using nuclear fission, okay, burning fossil fuels, or using a pumped storage hydroelectric scheme. It says outline which of the three generation methods above is renewable. By the word outline, it needs me to also explain it, and it's worth 2 marks. So I'm only talking about one of these. Okay, a lot of people try to put 2 down. I think that's because they've tried to put 2 marks. But the one that is renewable is your pumped storage. Okay, and then the outline is to explain why. So you could have said a few things like this, so like renewable can be replaced in a short time scale. You could have said that the source itself won't run out. We're not going to run out of the water. And even going into the fact that the water is used in the reservoir and is pumped back up and then falls back down again. So you could just have discussed the recycling of the water falling and going back up. Burning fossil fuels, obviously coal, oil, gas, we know that they are going to run out eventually, so they cannot be renewable. Nuclear fission, we're looking at, uranium-235. Again, they have a life. If we keep using it, they will eventually run out. So both of these are non-renewable sources of energy. For part B, it says in a nuclear reactor, outline the purpose of the heat exchanger. So we're looking at all sorts of power stations. We're looking at a reaction taking place. Specifically in a nuclear reaction, okay, we're looking at nuclear fission taking place. That's producing heat. The role of the heat exchanger is to transfer the energy from the reaction to the water and the steam that's going to go along to turn the turbine. So all you could say simply for this, all right, is it's the transfer of thermal energy or heat, okay, from the reactor to the water, okay, or you could say steam. Okay, you have to really reference the word transfer in here. And again, you can sort of start looking at the question itself, and it gives it away because we're saying heat exchanger. So the transfer, the exchange of heat from the reactor to the water steam that's then going to turn it around the turbine. Part 2 asks you about the moderator. A lot of people got confused between the moderator and the control rods here. The control rods are the ones that can lower down, or lower up and down, to control the rate at which the reaction happens. The moderator is the material, so often things like heavy water, which is used to slow down the thermal neutrons. So that was your first point to make, okay? You could say reduce or slow down, okay? So reduce the speed, or you could say kinetic energy. And again, you would need to say here of the neutrons. Because it's the neutrons that cause the further fission reactions, they need to see that word neutron. If you wrote particle, you don't get the mark for it. So you have to say reduce the speed, reduce the kinetic energy of the neutron. Okay? And again, the reason why we do this is so they can cause further fission reactions. Okay, so again, it would improve by slowing them down to that thermal speed to improve the likelihood of a fission reaction occurring, or you could say you could slow it down to make it more likely for the uranium-235 to capture the neutron. So I'm just going to summarize that here. So again, we would say improves the chance of the fission reaction occurring, or we could say improves the chance. So I'm just going to say improves the chance of uranium-235 capturing the neutron.